So this is going to be the answer key for the test review. The test will be on Friday. All right, for the first two, it says determine the transformations from the parent function, then identify its key characteristics. All right, so for this one here, what we're first going to remember is the standard form equation, which is going to be y equals a divided by x minus h plus k. All right, for number one, let's first start with the transformations. So we have x, we have y. So that negative on the top reflects it across the x-axis. And on the bottom, x minus 2 becomes right 2. So our vertical asymptote, if we just set the denominator, x minus 2 equal to 0, and we solved it, we would get x equals 2. Therefore, our domain is braces x such that x cannot equal the vertical asymptote. Remember, this is for functions that are in standard form, so in the transformation form. For our horizontal asymptote, it's going to be k. You'll notice there is actually no k there, so we assume that to be 0. So y is equal to 0. And the range braces y such that y cannot equal the horizontal asymptote, which is 0. On to number 2. All right, for number 2, we're going to start by stating the transformations. So we have x and we have y. All right, first I see that 2 at the top. That's going to be a vertical stretch by 2. The x plus 3, if we set that equal to 0, it would, or if we moved it, transformation would be left 3, insider's lie. And then the plus 1 is up 1. So for my vertical asymptote, left 3 is x is equal to negative 3. So braces x such that x cannot equal negative 3 as my domain. And for my horizontal asymptote, it went up 1, so y is equal to 1. Braces y such that y cannot equal to 1. Okay, for the next one, it says the rational parent function is reflected across the x-axis, then translate it 5 units to the right and 7 units down. Write an equation that could represent this new function, then identify the asymptotes. Okay, so for this one, I'm going to use the standard form again, y equals a x minus h plus k. And so for this one, let's go ahead and use that color. So first it is reflected across the x-axis. So the easiest one I'm going to do is y equal, we're going to make that a value negative 1. And then it says, and it's translated 5 units to the right, which would be x minus 5. And then 7 units down, which would be minus 7. So there is my equation that represents this new function. Then identify the asymptotes. So x minus 5, so for our vertical asymptote, x minus 5, so x is equal to positive 5. And for my horizontal asymptote, k is negative 7, so y is equal to negative 7. All right, given the following functions, answers number 4 through 8. Okay, so for each of these, what I'm going to do is I'm going to simplify them. So for this first one here, x squared minus 7x plus 6 becomes x minus 6, x minus 1 when you factor it. And on the bottom, x minus 6. Then we see we can cross out the x minus 6's. And this one simplifies to x minus 1. For the second one, we can factor out the 4. So we have x plus 4 divided by 4 times x plus 3. Notice there's no common factors that I can cross out there, so I'm going to leave it as it is. And then for this last one here, we can do the x method. So we have x minus 5 over, and here I'll do the x method off to the side just so you can see it. Or actually, I'll do it right above here. So you have negative 16 divided by ax, which is 3x. And then a times c, 3 times 5 is 15. So our factors would be negative 15 and negative 1. So that becomes 3x minus 1. And negative 15 over 3 reduces to negative 5. So that would be x minus 5. We can cross out our x minus 5s. When I write this one, 1 will be at the top over 3x minus 1. All right, so those are my 3 simplified ones. And again, I can always refer back to the original to see the domain restrictions if necessary. So the first one, it says, which functions have a y-intercept at -1? Okay, so all I have to do is plug in 0. So for f of x, if we plugged in 0, we actually would get -1. So like right there, it would be 0 minus 1, which is -1. So your y-intercept there is -1. So that's f of x. Here, if you plugged in a -1, you'd have 3 on the top over 8, which is not -1. And for h of x, oh, sorry, if you plug in 0, 0 plus 4 is 4. 0 plus 4 is 4. And 0 plus 3 is 3. 3 plus 4 is 12. So even then, it's 1/3. That wouldn't work. Over here, if you plugged in 0, 1 over -1, which would be -1. So this one works as well, which is h of x. So f of x and h of x both have y-intercepts at -1. Which function has a hole, a removable discontinuity? So anything that we cross out, so f of x, we cross out x minus 6, which means there would be a hole. We did not cross out anything in g of x, and in h of x, we did cross out the x minus 5, so that also would create a hole. So it's going to be f of x and h of x. Number 6, what is the horizontal asymptote of g of x? Okay, so we can just look at the original function, and we see they have the same degree, x to the first over 4x to the first, so we can just divide those and put this right down here on the bottom right. So x divided by 4x, which gives me y equals 1/4. What is the domain of h of x? So here I'm going to go back to the original domain, or to the original function, 3x minus 1, x minus 5. So braces x such that x cannot equal. So I would solve these. The first one would be 1/3. And x minus 5 equals 0 would be 5. So that is my domain for h of x. Number 8 says, what is /r the vertical asymptotes for f of x? Well, for f of x, when you simplify the equation, you get x minus 1. But here, we have no denominator. So in terms of our asymptotes, there are none. All right, let's continue on. All right, for number 9, 10, and the rest, it says, graph each function, identify its key characteristics, must show at least one point on the left and right of the vertical asymptote. Okay, so here we go. Number 9 first. So for number 9, it's in its standard form. So our vertical asymptote, x plus 4, set that equal to 0. So x equals to -4. I'm going to go ahead and graph that here. So there's my vertical asymptote of x equals -4. And hopefully you recall the understanding that in terms of standard form, that is your domain restriction. And for my horizontal asymptote, it's k, so y is equal to -7. So there's my horizontal asymptote. And my range, y such that y cannot equal to -7. Now for this one here, we know the branches are supposed to be in quadrants 1 and 3. Since this is positive, it would say 1 and 3. If it was negative, it would switch to 2 and 4. But let me go and show you what we've been doing in class. Since there are no points that we can actually plot, so we look at our vertical asymptote, which is at -4. I always pick a number to the right, which would be -3, and one number to the left, which would be -5. I test those 2 points, and I create x and y, so I can plot 2 points, so I know where my graph is. All right, so we'll start with x equals -5. All right, so I'm going to plug it into the function. So y equals 1 over -5 plus 4 minus 7, which is 1 divided by -1 minus 7, which is -8. So I just created a point, -5, comma, -8. I'm going to go ahead and plot that point. And now I can see that it's in quadrant 3. So I'm just going to make my graph where it gets close to the branches get close to the asymptotes without crossing or touching. There's my first branch. Now I know my other branch is going to be in quadrant 1, but I'm going to verify where the point is. just so I can make my graph nice. Alright, so we're going to test now x equals negative 3. Plug it into the function. This would be 1 over 1, which is 1, and 1 minus 7 is negative 6. So my second ordered pair is negative 3, negative 6. And there we can see it's right there. And this one I'm going to try my best to draw it without making it look too bad. So get close to the asymptote without crossing or touching. Same with the horizontal. And there's my graph. All right, I'm going to continue on to number 10. All right, for number 10, same thing. It's standard form again. So this time, vertical asymptote, there's nothing with x, so x equals 0. So braces x such that x cannot equal to 0. Let's go ahead and graph this. This is a little bit harder to see. Sorry about that. For my range, y equals k, so y equals 3. Sorry, horizontal asymptote, y equals 3. So for my range, y such that y cannot equal to that 3. All right, now we're going to test our points. So currently we're at 0, so 1 to the right is x equals 1. 1 to the left, x equals negative 1. Start with x equals negative 1. So y equals negative 2 over negative 1 plus 3, which is 2 plus 3, which is 5. So we have our first point at negative 1 comma 5. And we can get close to our asymptotes without crossing or touching. And now we're going to test x equals 1. So y equals negative 2 divided by 1 plus 3. Negative 2 divided by 1 is negative 2 plus 3, which is 1. So now we have a point at 1 comma 1. And we're getting close to the asymptote without crossing or touching. And there's my graph for number 10. All right, let's go ahead and move on to number 11. All right, and then 11 is going to be, literally looks like, yeah, it's going to be a general form. So we may have x in the top and the bottom. So I'll do all this work first. Now, the order I'm going to solve it, x-intercept, y-intercept, vertical asymptote, horizontal. I'm just going to go down that line there. All right, first thing we want to do is we want to simplify this equation here. Actually, we want to find the horizontal asymptote. So if you look at the degrees, you have x squared on the top, and you have 2x to the first on the bottom, so squared is bigger, so therefore your horizontal asymptote is none. All right, and I'm going to go ahead and factor now. Again, I could have done that afterwards, but I just chose to do it right now. And I'll come back and show you again. All right, so on the top, we can factor out an x. And on the bottom, we can factor out a 2. And we see our common factors are x plus 6, we can cross out. So now my simplified equation is x over 2. All right, and that's my simplified equation. The rest of my answers will come from here. All right, we're going to start with the x-intercept. We set the simplified numerator equal to 0. In this case, we have an x. So if x equals 0, then our x-intercept is 0, 0. For our y-intercept, we plug in 0 for x, so y equals 0 over 2, which is 0. Then we go to our vertical asymptote. And for our vertical asymptote, we have no x in the denominator, so there is none. A horizontal asymptote, we figured out was none already, because the degree is highest on the top. And then we have RD, our removable discontinuity, our hole. Here we did cross out x plus 6. We're going to set that equal to 0 and solve it. So x is equal to negative 6. Then now we're going to plug that into our simplified equation to figure out our y value. And there's our information. Okay, so for our x-intercept and y-intercept, they're both 0, 0. Our vertical asymptote was none. Our hole was at negative 6, negative 3. And for our domain, we know that x cannot equal the vertical asymptote, which is none, and the x value of the whole, which is -6. And for a range, y cannot equal the horizontal asymptote, which is none, and the y value of the whole, which is -3. All right, and let's go ahead and make our graph now. So from here, there's no asymptotes to graph. So I'm going to graph the points that it gives us. So we have -6, -3, and that is a whole. And then we also have our x and y intercept at 0, 0. And this actually turns into a line if you think about it. This can be written as y equals 1/2 x, where our y-intercept is 0, and our slope is 1/2, so we rise up 1 and right 2. You'll notice the shape of the graph I'm taking is just a linear function. If I go backwards, down 1, left 2, I should intersect that. Yes, the hole is right there. And now we're just going to make our graph. And it's discontinuous at that hole that we created. And there's our graph. It is a line. All right, there's number 11. Let's go ahead and move on to number 12. All right, number 12, same thing. Here, if you'll notice, the degree on the top and the bottom are the same. So we're going to go ahead and divide them over here. So y equals x squared divided by x squared, which is 1. So there is your horizontal asymptote. Now for the rest, we're just going to simplify this. So this becomes on the top x minus 8 and x minus 3. This will be x plus 3, x minus 3. And you see our common factors of x minus 3's. So our simplified equation will be x minus 8 over x plus 3. There's my simplified equation. All right. And again, let's just start from the top. So x-intercept. So we're going to set our numerator equal to 0. So x minus 8 equals 0. Add the 8 over. X equals 8. So we have an x-intercept at 8, 0. For my y-intercept, you plug in 0 for x. So y equals 0 minus 8. 0 plus 3. So y equals -8/3. For our vertical asymptote, we do actually have a denominator here. It's x plus 3. We set that equal to 0. We subtract the 3 over, and x equals -3. We already did our horizontal asymptote. The degrees were equal, so y equals 1. And for our whole, we crossed out x minus 3, so we're going to set that equal to 0. We're going to solve that. And then we're going to take x equals 3. We're going to plug it back into our simplified equation to solve for y. So y equals 3 minus 8 over 3 plus 3, which is -5 over 6. So we get -5/6. All right, so let's go ahead and fill out our information. So my x-intercept is 8, 0. Y-intercept is 0, -8/3. Vertical asymptote, x equals -3. Our whole is 3, -5/6. Our domain, x cannot equal the vertical asymptote, -3, and the x value of the whole, 3. And for our range, y cannot equal horizontal asymptote, which is 1, and the y value of the whole, which is -5/6. And now let's go to make our graph. Okay, so our asymptotes were at x equals -3. And y equals 1. All right, let's go ahead and graph the rest of our information now. So we have an x-intercept at 8, 0. Right there. We have a y-intercept at 0 and -8/3, which is like 0 and -2 2/3. So right around here. We have a hole at 3, -5/6. 3, close to -1. So right there. And there we go. So based on this, we know that our other branch should be in quadrant 2, but we do have to test it. So I already have a number to the right of x equals -3, so I'm going to test -4. I'll just do that right here. So if x is equal to -4, we're going to go ahead and plug that into our simplified equation. So y equals x minus 8, so -4 minus 8 over -4 plus 3, which is -12 over -1, which is 12. So let's go and go -4, positive 12, which is somewhere up here. And just make your graph. This one goes up like that. And there you go. There is your graph. All right, and now we just have one more to do. Let's take a look at number 13. For this one here, when I compare the degrees, we have a power of 1 on the top and we have a power of 2 on the bottom, which is bigger. So this right here by default will be y is equal to 0 for our horizontal asymptote. Remember, top is none, bottom is y equals 0. If they're the same, you divide them. All right, let's go ahead and simplify this now. All right, so here we can factor out a 3, which is x plus 1. And for my factoring here, I'm going to go do this off to the side just so you can see it. So you have 9, 2 times 7 is 14, divided by 2x. So our factors would be 2 and 7. So our first one would be 2 to which is 1, so that's x plus 1. And the second one is 2x plus 7. Here, hopefully you can see that our common factors are x plus 1, so we cross that out. And so my simplified equation is y equals 3 divided by 2x plus 7. All right, and let's just start from the top. So x-intercept. You'll notice we don't have an x at the top, so there is none. Y-intercept, we plug in 0 for x, so y equals 3 over 2 times 0 plus 7. So y equals 3 over 7. For my vertical asymptote, set the denominator equal to 0, so 2x plus 7 is equal to 0. We're going to solve it for x, so subtract 7. Divide by 2. X equals -7/2 or -3.5. Now, horizontal asymptote we already got, and now we're going to do our RD last. So we did cross out x plus 1. We set that equal to 0, and then we solve it. So x equals -1. And to figure out our y value, we plug in -1 to simplify. So y equals 3 divided by 2 times -1 plus 7. And then we get 3 over -2 plus 7, which is 3 over 5. So y is equal to 3/5. All right, so let's go and write information. So none and 0.3/7. Vertical asymptote, x equals -3.5. Our whole, -1 and 3/5. And for our domain, x such that x cannot equal the vertical asymptote, -3.5, and the x value of the whole, -1. For our range, y such that y cannot equal the horizontal asymptote and the y value of the whole. All right, let's go ahead and graph our asymptote, so -3.5. And y equals 0. Let's go and graph our information. So we have no x-intercept, 0 and 3/7. So that's about halfway to 1. 0, half almost. We have a hole at -1 and 3/5. So negative 1, and 3/5 is a little bit more than half, so somewhere like right here. And that's all we have there. So this one just looks like this. All right, and I do not have a point that's to the left of negative 3.5, so let's go with negative 4. Make it a little bit easier on ourselves. So if x equals negative 4, to figure out y, we plug into simplified equation. So 3 divided by 2 times negative 4 plus 7. 3 over negative 8 plus 7. So that's going to give me 3 over negative 1, which is negative 3. So negative 4, negative 1, 2, 3. And that makes sense. There's our branch here. And here is our other branch. All right, and that concludes in the test review answer key.